Alright, welcome everybody to the general video discussing the chain rule. Now, coming into this particular lesson on the chain rule, there needs to be some familiarity with composite functions, meaning we're putting functions within functions, which we'll get practice with the next couple of days. But understand that this is a unique situation where we're taking a function to either a power, a very, very high power, or we're dealing with radicals, which in these example 3 and 4 is our problem there. So when we want to use our chain rule, the thing we're kind of looking for is either a radical, and really in any instance, any kind of index for this, and then maybe a particular function taken to a power. And we would use a chain rule if n is greater than 2, look to use a chain rule. So if this were like a 4, 5, 6, 7, 8, obviously we don't want to sit here and break it down algebraically. I mean, in class the other day we just had 3 to the third power, and that still took a little bit of time. So you'll kind of distinguish when to use a chain rule and when it can be used. Of course, if you wanted to, you can always simplify the ones that are taken to a power. We could actually take 2x to the third plus 9x to the fifth power if you wanted to, FOIL it all out, find what that is, but obviously that would take an extraordinary amount of time, and if you make one little mistake, then everything's kind of going to be wrong. So that's kind of what we're looking for. So when we have a lot of problems altogether, when we see like either a radical with a function inside that or a function taken to some high power, that's kind of a signal that we're going to use the chain rule. So let's kind of go over the basic deals with the chain rule. In this case, we're taking this particular function to the fifth power, right? And I explained this idea of substitution because substitution helps to kind of minimize the confusion when we're working the problem. So say, for example, what we described the other day was u, okay? So we're going to describe u as the function 2x to the third plus 9x. Now it's not random that I chose the variable u. In the chain rule we kind of use this variable to kind of sub in into the function. So now what we're going to do is we're going to say, all right, well, u to the fifth. Okay, so I've replaced this whole function with 2x to the third plus 9x. Now this is just a method of kind of simplifying the problem so it doesn't get too complicated real quick, because this is kind of a generic version of what the chain rule states, is the idea that I'm taking the derivative of the function around the g of x function, then taking it times the derivative of the g of x function. So by doing this, we're replacing this function inside here with u. Okay, so now if I gave you this as a particular problem, all right, you would say, all right, well, I can find the derivative of that. I bring down the 5, take 1 off the exponent. Okay, so that's great. We just use the general power rule. Now what we're going to do is we're going to stick u back into the function. So now we have y equals, it's a derivative of y, dy dx. Is we're going to put this back in here. This case it's du, dy du. But sorry, 5, and we got 2x to the third plus 9x to the fourth. So notice all I did was I stuck u back into the problem. Now don't forget that we also need to take the derivative of our u. So that would be 6x squared plus 9. All right. So now it's important though that this is, if we want to really simplify it, we got to understand that this is a binomial in itself, and so when we take it times 5, that would be y equals 5 times 6x squared plus 9 times 2x to the third plus 9x to the fourth. And then what we can do is we can distribute the 5 and kind of simplify it a little bit more. So our kind of end result here, our end idea, is 30x squared plus 45 times 2x to the third plus 9x to the fourth power. Okay. Now obviously if you were to sit here and say, all right, well, I'm going to just take this whole thing times that, obviously you'd come up with a not a good answer, I would say. Okay. So obviously this is going to simplify things for us, and for right now, if you just wanted to stop here, that is also okay. We're going to spend some time in the simplifying era, especially when it came to those product and quotient rule. We're going to spend some time with that later on in this chapter. Okay, so that is a general rundown of the chain rule. Some of you guys came to that conclusion when we were working it with just the power rule. I was proud to see that some of you guys came up with that. Let's see here. So now let's talk about a different case here. Like I say, I'll just work some different example problems here for you. So let's say example 2, k of x. Okay, so k of x equals negative 2 parentheses 12x squared plus 5 to the 6th power. Okay, so what I want to do here is same process that I did. I'm going to see, okay, there's a function and it's taken to some power, so I'm going to call that u. U is going to be, bad equal sign. U is going to be 12x squared plus 5. Okay, so then I would say, all right, I'm going to rewrite it with the u in place of my function. So now I have k of x equals negative 2 u to the 6th. Okay, now if I just use my general power rule here, I'm going to get the parentheses, derivative of this is negative 2. Sorry, I got to take the derivative, don't I? Hold on a second. That would be negative 12, because I take 6 times negative 2, which would be negative 12 u to the 5th. Okay, and now what I'm going to do is I'm going to put that u back in there. So I'm going to have k parentheses negative 12, 12x squared plus 5 to the 5th power times the derivative of the u function, which in this case is 24x. Okay. And then if we want to simplify it, we can, but for right now, like I said, I'll stop there and just say, okay, this is the derivative of this particular function here. Okay, so again, go back to kind of review that again. Like I said, with most of this stuff, it just takes a little understand what's going on here. The last problem I'm going to do, because I'm going to leave example 4, is going to be an excellent discussion piece for us moving forward. But for right now, I'm going to work a problem that deals with a little bit more of the radical sense. So I have something taken to a fraction or a fractional exponent. So, and I'm not going to take too much of your time here. If we have RT equals 45 parentheses 3t to the 3rd minus 8 to the 3 halves. Now, some of you guys have already kind of seen what we're going to call u, which is great. It's great to kind of get in the habit of just identifying that. And so we have u equals 3t to the 3rd minus 8. Okay, and so now we rewrite the problem with u involved. So that would be 45 times u to the 3 halves. And then when using the power rule, we take is that the right? Yeah, I'm doing all right. We're going to take 3 halves times 45. So 3 halves times 45 would be, let me get my calculator real quick. 45 times 3, it's going to come out as an odd number. 43 times 3 divided by 2, which would give us 67.5. But what I think I'm going to do is just leave it as 135 over 2, over 2, u to the, and we're going to subtract 1 from that, so that would be 1/2, times, let me write this in here, let's go, derivative of this is 135 over 2, I'll put u back in there, 3t to the 3rd minus 8 to the 1/2 times, so again all I did was I put u in there, okay, times the derivative of this, which in this case is 9t squared. Okay. Now again, I could multiply the 135 over 2 times 9t squared, so on and so forth. But for at this point in time, I'm just going to leave our answer just like this. It looks more complicated than the original problem, but understand that there's no way algebraically for us to take 3t to the 3rd minus 8 to the 3 halves power. You can't really foil that or do anything crazy with that. So we have to use this particular method. So this is your answer here. Now example 4, I want you guys to attempt. You'll notice that there is a problem, and I want you to see if you guys can come up with that answer. And we'll talk about it tomorrow and maybe the next day. So have a great night, and I'll see you guys all tomorrow. Thank you.